Arthur C. Clarke once famously said that either we are alone in the universe or we're not, and both prospects are equally terrifying. Many in my comment sections over the years have said that, well, why would being alone be particularly terrifying? After all, there's no real threat in that case, as opposed to being conquered in an alien invasion of Earth. While that might seem reasonable on its face, the fact is, if we are alone, and Earth is the only planet in the universe with life in general, and it's still managed to produce a technological civilization, then the universe itself and its very nature immediately come into question. The reality is that us being alone is actually the more frightening prospect as opposed to alien life existing. It has to be said that, first of all, if we are actually alone, we can't ever prove it. We will never know if we are the only life in the universe. We can only make a discovery of alien life and know that we are not. The reason we can't know is the universe itself. It simply does not allow us to. We can only see a bubble, the observable universe. The universe continues beyond that boundary, however, and whether the universe is only a little larger, much larger, or infinite is up in the air. But the reality is that, no matter what, we can't see all of it, and as a result, we can't know if we are truly alone. And there's the time factor. The further you look out, the further back in time you see, and that means that the furthest objects in the universe we see are from when the universe was very young, and not populated with the heavier elements needed for life to arise, at least our kind of life. That shrinks the bubble even further. But life itself may be easy to detect, and may happen within my lifetime. We can search Mars for life, and there are plans to do so. Same with Venus. We can look at its upper atmosphere and determine where the mysterious phosphine gas is coming from. Further, we can look at the large number of ice shell moons we have, and try to determine if their oceans host life. It's certainly possible that we live in a star system that could have over a dozen instances of independent life arising. Think about that for a moment. Obviously, we know Earth spawned life, but scientists have identified some of the conditions needed for life to arise. So far as we understand it, potentially at Venus, Mars, Europa, Ceres, Enceladus, Titan, Triton, Ganymede, Callisto, Pluto, and so on. I've talked about those on this channel, but there are more. What of Oberon, Miranda, our own moon subsurface, Io, Dione, Rhea, and Titania, but also the Kuiper Belt objects, such as Orcus, Maki-Maki, Gong-Gong, Eris, and Sedna, and very likely a myriad other distant solar system objects that could sustain the conditions needed for liquid water oceans, due to circumstances like radioactive decay in their cores. Water is everywhere. Our solar system is not unique in this regard, that much we know. You could even make the case, as Carl Sagan once did, that the universe may even allow for gas giant life. He thought of the possibilities of gas giants or even brown dwarfs hosting complex life uniquely adapted to those circumstances. Think floating gas bags, very much unlike anything on Earth, existing in ecosystems, adapted for living in the upper atmospheres of gas giants, ending their life cycles through dying and falling into the crushing pressures below. Decomposition would not be a process in such environments. Something gives up the ghost and immediately drops into the gravity well, and that's that. But there's also the opposite scenario. Freeman Dyson envisioned Dyson's sunflowers, life that evolves on ice shell moons in order to reach out for the surface through fissures in the ice to discover the sun and evolve petals, if that's the right word, that reflect sunlight in the almost vacuum of the surface of an ice shell moon to a central point in the organism to provide the energy needed to sustain life. A new kind of photosynthesis analog indeed. But Dyson went even further with his ideas. What if such an organism developed and evolved and became independent of its subsurface ocean somehow, and became free-floating to populate space in the star system itself? I think this is a stretch. A lot is stacked against that kind of life. But what I do know is that if such life existed out there in the solar system, our current instrumentation would not see it. We have no idea if the solar system has done anything like this. It's far too early to assume that since we haven't seen it, it probably doesn't exist. We're very far from that territory. Indeed, the best way to look at the Great Silence is to recognize first that we've only just barely started looking, and it should be no surprise that we haven't seen anything yet. But that is a function of time. What if after centuries we still haven't seen anything? And we found that Earth is the only body in the solar system hosting indigenous life. What if after thousands of years of studying exoplanets, we still haven't found the slightest hint of an alien biosphere or technosignature? What if, after an immense amount of time and study, we still appear to be alone? The wild card in this is figuring out abiogenesis and how easy or hard it actually is in practice. If it's hard, we'd be able to say that we're probably not alone, we're just very rare, and it's unlikely that we'll ever see aliens. If it turns out easy, and recent work is showing parts of that process to be easier than predicted, and we still see no evidence of alien life, then we have a conundrum indeed. A great silence where there shouldn't be one. But it may also be the case that we never know what the complete process of abiogenesis is, and it simply can't be figured out, leaving the question open forever. But in recent years, there has been a trend in skepticism towards the conclusion that since we haven't seen any evidence of alien life, it must not exist. This is problematic, because it comes with implications that have not been well explored and are frankly unsavory. The chief issue is the Copernican principle. At its most basic, it states that we occupy no privileged position in the universe. We look out into space, and it more or less looks the same no matter what direction you look. Observational astronomy leans heavily on this mediocrity principle. If we really are alone, however, this principle goes out the window. In that scenario, then Earth takes the cake as the most privileged spot in the entire universe, the one place where a certain type of organic chemistry occurs that happens nowhere else in the universe. Unique chemistry, an island of unrepeatability amid an eminently repeatable experimental science. This world then becomes something akin to the island from Lost, the one magical place in the whole universe where consciousness exists, which amounts, if you think about it, to the universe perceiving itself. In this case, we are magical unicorns. But the problem of being alone goes much deeper. In science, you typically assume that when you observe something, say an asteroid, that since you saw it relatively easily to begin with, it must be part of a greater population of like objects. If you see an asteroid right off the bat, chances are if you keep looking, you'll see tons more. For some reason, this is not applied in skepticism towards the overall existence of alien life. We self-prove the concept that it can happen. We are someone else's alien civilization. So why wouldn't it be reasonable to expect that our civilization is just one of a population, could be any size, in the universe? Sure, we haven't seen anyone else, but absence of evidence isn't evidence of absence. This is why most scientists assume alien life exists out there somewhere, because it's the simplest answer, an application of Occam's razor, if you will. This is mainly because of the sheer number of chances for it to happen. Stars ostensibly capable of hosting habitable zones are the most common stars in the universe by far, and we know now that exoplanets are not rare. We've found thousands of them at this point. We've seen them within the habitable zones of their stars, a good example being the TRAPPIST-1 system. And this is where we come up against some very serious odds. It's extremely difficult to understate this point. We live in an observable universe that contains an estimated 200 sextillion stars, the vast majority ostensibly hosting habitable zones, over 90%. This is what a very large national lottery odds look like, at least in the US. 1 in 175,711,536. Going very conservative and saying that only about 0.5% of stars have suitable planets in their habitable zones for life, the number is likely significantly higher. This is what the odds of the Sun being alone in hosting life look like. That's right, one with 21 zeros behind it. If we are alone, we beat some of the worst odds possible in the universe. And if we somehow did that, make no mistake, you are amongst the rarest, most important occurrences ever to happen in the entirety of the universe. Again, your own odds for existing are so bad that you're beyond a unicorn. They have nothing on us. You are some kind of singularity. You are so beyond unlikely, it's just incomprehensible. The simplest answer really is that the universe teems with microbial life, often produces more than that, and occasionally produces civilizations. If it doesn't, then we will really seriously need to ask some deep questions about the nature of the universe, and if what we see really represents reality. After all, without the Copernican principle, we can't know if we occupy a privileged vantage point, and against all odds, we can't know much of anything. Now, people will try to make the case that such a thing just proves a deity or a simulator exists. But this is fraught with problems as well in an "are we alone" scenario. For example, if there is only one civilization present in the universe and that's the point of it all, then why is it impossible to see or really interact with the entirety of the universe? Why just an observable bubble, with the rest being imperceptible and useless? It wouldn't serve the presumed objectives. It would just be an inefficient waste, painting a somewhat grim picture of whatever created it. Still, others will argue that intelligent life is simply rare. But maybe the universe has all sorts of life, but it just doesn't get to our level. That's certainly a valid point. There's plenty of intelligence in the animal kingdom, but none to our level. But at the same time, we're not the only species of human to have existed. Our extinct relatives were close to our level, using tools and fire. And that suggests that once you do hit intelligence on a world, it becomes increasingly common in an intelligence explosion. And that may also hold true for the universe. And that in the far future, alien civilizations become more common, due to having had more time to develop. But the overarching question remains, what if during the whole of our existence, we see no indication of alien life, and for all intents and purposes, we are alone? It makes for a very strange and spooky universe indeed, and a very lonely one. In all the vastness and darkness of space, we would be the one lone voice in the void. Alone here, marooned if you will, for either a purpose or no purpose at all. And that's what Arthur C. Clarke meant when he said that the two options are equally terrifying. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently addressing the vocal detractors of candy corn in the comments section. I actually like it, but I grew up with it everywhere in the 70s and 80s, along with such controversial, contentious candies such as circus peanuts, which are apparently supposed to be banana flavored but shaped like peanuts. Not sure what the inspiration for that was. And of course, black licorice. I actually like them all, but that's because I like all candy. But being diabetic, have to avoid it, so for me, Halloween is a bittersweet holiday, leading to much pining away for sugar amid a cool, spooky atmosphere. Once again, the universe has betrayed me. And do tell me what your favorite candy is in the comments below, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular, in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.